Hi, this is Math Kimchi, and today I will be creating a function that does things with matrices. And in this video, I'll just be working on scalar multiplication and also matrix addition. So for scalar multiplication, all it does is it multiplies each element of the matrix by some scalar number, and a scalar is any number that's not in a matrix. So, for example, if the matrix was uh, 1, 2, and 3, 4, then the scalar, and if the scalar was, for example, 2, then S m or S times m would be equal to 2, 4, 6, 8. And as you can see, 2 is just 1 times 2, 4 is 4 times 2, 6 is 3 times 2, and 8 is 4 times 2. And scalar multiplication is probably one of the easiest things to do with matrix. So scalar mult, and it takes in a scalar and a matrix, and I'm going to create a new empty matrix, which I'm going to call product m, and for now it's just going to be an empty list, even though I'll be using a list of numbers as matrices. And so all we really have to do is go through everything inside M and multiply it by S. And to do that, we just go through every row for row in M. And for every row, we go through every element in the row. And actually, I'm just gonna create a product row. And this is going to be an empty list, and I'm just gonna rename this to product matrix instead of product m. And so for every element in row, product element will just be equal to element times s, and we just add product element to product row plus equals row. Or actually, I'm just gonna do dot append. Wait, no, this is backwards. It has to be product row dot append and then product elements. And once we have gone through every element in the row, we just add the row to the matrix. Matrix dot append and product row. And that should be it. So now let's put in print scalar mult, and we'll be multiplying 1, 2, 3, 4 by 2. So now if I run this, oh, I'm not returning product matrix. That's pretty important. Return product matrix, and if we do, we get 2468, which is the expected result. And that's it for scalar multiplication. And now let's get on to matrix addition. And this requires two matrices, which I'll be calling M1 and M2. And when we do matrix addition, so let's say this was M1 and M2 was something like 5, 6, or sure, 5, 6, and 7, 8, then M1 plus M2 would be equal to 6, 8, 10, 12. As you can see, this is just 1 plus 5, 8 is 2 plus 6, 10 is 3 plus 5, 3 plus 7, and 12 is 4 plus 8. And this is kind of similar to scalar multiplication. All we have to do is go through every single row, and for every single row we go through the element and we just add the two matrices. And so, like scalar multiplication, I'm first gonna have a product or a sum matrix, which starts out as an empty list, and actually before that I'm going to add a dimension checker. So I'm going to do that in a separate function. So def dimension, and all this does is return the number of rows and then the number of columns. So the number of rows is just len m, since every list inside of a matrix is a row. And to find the column, we just have to see how long each row is, and I'm just going to check the 0th or the first row depending on how you look at it. And the reason why I'm doing the very first one is because if we were to do something like m of 6, then it would work if there were 7. Yeah, so if there were 7 or more rows, but if there was 6 or less rows, then we would get an error because the matrix doesn't have a 6th row. But I can guarantee that it always has a 0th row, or a 0th or a first row. And all we do for this is check if both dimensions are not equal. And not equals is exclamation equals, and And the reason why we're checking if the dimensions of M1 and M2 are not equal is because the matrix addition only works if both matrices have the same dimension. And in this case, if this was true, then they do not have the same dimensions. So let's just print like error dimension mismatch, and it returns nothing. Yeah, and we don't need an else since we already have a return. And if it was here, then it would mean that it didn't return anything, which would mean that this was false. And so we just have to create a sum matrix first, and it's an empty list like in Scalar Mult. And with the sum matrix, we're just gonna go through every single element in M1 and M2. And to do that, instead of doing something like this, I'm actually going to do this. And it doesn't matter if it's M1 or M2. And the difference between this and this is that in this, row would be equal to some element in M, whereas in this, row will be equal to a number from 0 to how many elements there are in M1. And the reason why that's important is because then we can get M1 and M2, whereas here it'd be harder to find what the corresponding value for M2 would be. And so now we just have some row, and that's also empty at first. And now we just go through every column, and I'm also gonna do something similar to this. We're gonna do range 0, and instead of finding how many rows there are, I'm gonna find how many columns there are by doing len M1 and 0. And it's okay that this is 0. I think it will still work if I do row, but it shouldn't matter since in a matrix every row has the same amount of elements. And now we just do some element equals M1 and row column plus M2 row column and we just do some row dot we just add some element to some row. So some element. And once we have gone through everything in one row, we just go through, or we add the sum row to sum matrix. So matrix dot append sum row. And once you're done, we just return sum matrix. Alright, so let's see if this works. Okay, so this should print 6, 8, 10, and 12. 6, 8, 10, 12. So it's working, and let's check if the dimension is working. So if we were to give M3, so these are both 2 by 2, but if we were to make M3 2 by 3, so I'm just gonna do 1, 2. Wait, 2 by 3 would mean it has 3 columns, so 3 and 4, 5, 6. So now we should get a dimension mismatch. And we do, and we get a none because it returns just nothing. And we should get something similar if we have a 3 by 2 matrix. So 1, 2, 3, 4, but we go and add 5, 6. So we add a third row, and we should get the same thing we got when we made M3 a 2 by 3 column, or a 2 by 3 matrix, and we get the exact same thing. So that means that it's working, and that was it for this video. Thanks for watching. Bye.